Have you ever wondered how, in the vast universe of atoms, electrons manage to flow and create the energy we use every day? It's a fascinating journey, and it all starts with the Bohr atomic theory. Bohr atomic theory, named after the brilliant Danish physicist Niels Bohr, is a concept that revolutionized our understanding of the atomic world. It proposed a planetary model where electrons orbit the nucleus, much like how planets orbit the sun. But unlike planets, electrons occupy specific energy levels, or shells. In the first energy level, closest to the nucleus, there can be 2 electrons. The second level can hold 8, the third can hold 8 as well, and so forth. Each of these energy levels is quantized, meaning electrons can't just be anywhere. They must occupy these particular spaces. Now, what happens when an electron absorbs energy? It jumps to a higher energy level further from the nucleus. And when it loses energy, it drops back down to a lower energy level, closer to the nucleus. But what if the electron absorbs enough energy to jump beyond the outermost energy level? It becomes a free electron, leaving the atom entirely, and this is where our story of electron flow begins. In a conductor material like copper wire, atoms are packed closely together. Each atom has 1 or 2 free electrons in its outermost energy level, constantly jumping from one atom to another. This is the random motion of electrons. Now imagine applying a potential difference, or voltage, across the conductor. This voltage creates an electric field within the conductor. Suddenly, these randomly moving electrons feel a force. They start moving from the negative terminal towards the positive terminal of the battery. This directed movement of electrons is what we know as electric current. Remember, it's a common misconception that current flows from positive to negative. In reality, it's the electrons carrying negative charge that move from the negative terminal to the positive terminal, creating what we call conventional current flow. So, to sum it up, the Bohr atomic theory helps us understand how electrons exist within atoms and how they can become free. These free electrons in a conductor move randomly until a potential difference is applied. This causes the electrons to move in a specific direction, creating an electric current. Bohr's atomic model and the concept of electron flow are fundamental to many aspects of science and technology, from the functioning of your smartphone to the electricity that powers your home. And it all starts with the understanding of how a tiny particle like an electron, in the vast universe of atoms, can create such a powerful force.